A virus is much smaller than a bacterium and can only be seen under an electron microscope. They can't reproduce on their own and need to invade living cells to multiply. This unique time-lapse photography shows a virus invading a human cell. As the virus enters the human cell, it hijacks the cell's reproductive machinery and starts to multiply. Viruses like HIV and herpes can't be seen under an ordinary microscope. What can be seen is the damage done to human cells by the virus. Once the virus enters the body, our white cells make chemicals called antibodies.
Antibodies can be detected in serum. This is the clear layer here from a patient's blood sample. These samples have been allowed to stand so that the red blood cells are settling at the bottom and the serum can be seen at the top, and it's this layer that we use for antibody detection.
All HIV tests need a few drops of serum. In this test, 14 different people can be tested per slide. Each well contains chemicals which bind with HIV antibodies. A stain makes the HIV antibodies change colour. Under the microscope, the left sample doesn't contain antibodies. The right one does. Viruses that cause killer diseases like smallpox and polio are controlled by vaccines. Vaccines contain small doses of specially weakened viruses. Diseases are prevented by infecting people with these weakened viruses. The vaccine triggers the immune system to produce antibodies which defend us from harmful viruses. Unfortunately, HIV can't be so easily prevented because it attacks the body's defences, the immune system. We make thousands of different types of antibodies for each different type of virus. If a gang of viruses revisits your body, the antibodies will recognise them and zap them. If they're strangers, new antibodies will be made to attack them. These new antibodies will be on standby in case the gang revisits. Vaccines warn the immune system to recognise viruses and make standby armies to attack them. But some viruses are smart. They can change shape or disguise or hide inside normal cells. Certain white cells called T helpers act like sniffer dogs, sniffing out these smart viruses. They warn the system to make the right kind of antibodies. Developing a vaccine against HIV is difficult because the virus is the smartest of them all. It uses disguise and changes shape and hides inside cells. At first, the sniffer dogs are good at warning us to make antibodies against HIV. But after a while, HIV invades them and multiplies. The new HIV viruses kill more T helpers. And when most T helpers are dead, the immune system can no longer defend itself against disease. Healthy people have thousands of T cells, and it usually takes years for HIV to destroy them. That's why most HIV-positive people stay well for a long time. Until a cure or a vaccine is found, medicines like AZT are being used to help people with AIDS. Unfortunately, some people can't tolerate these medicines for long periods.